starting lecture 18. In lecture 18, we talk about operating system and virtual memory introduction. Okay, we can find in our agenda OS introduction. We must see and study. You have one class named operating system. So in our class operating system, we talk about introduction and related content. Okay, this is discrimination. When we run Linux, it only executes one program and then stops. This is a long time ago. When I switch on my computer, I have many programs. So in current operating system, we find many programs, many processors, many running programs is running in the memory. So we can find we can use software. The software is the operating system. So the operating system is system software. So the operating system can administrate all programs, all softwares in the operating system. So we regularly talk. The operating system is a platform. The platform is very useful and necessary and important. So the operating system, you can find software can find. This is the size of operating system. It has 84 million lines of code. So you can find this is some example. This is Windows Vista. This is Facebook. This is U.S. Army Mutual Combat System, and this is large pardon coder. This is Mac OS type. So you can find this is the size of operating system, the size of code. Okay, this is operating system. We can use three levels. One level is computer hardware. Computer hardware is all hardware in computer organization. Above the computer hardware, we can see operating system. Above operating system, we can see all software or all applications. So you can find in the cell phone all app. What is app? App is application. So software, all software in the platform, we can find the software, more powerful. So we like software. We like more and more software. We like free software. Okay, operating system control. How software applications access and use hardware on your computer. They provide a general interface for common actions. For example, reading, writing, the operation. The reading, writing is the disk and allow software to run without knowledge of the machine it lies on. Please be careful. SSD. SSD is solid state disk. This is the current disk in laptop. And the SSD, the speed of SSD is fast, then is quicker than hard disk. Yeah. So we like SSD. We like SSD run in our laptop. For example, the SSD, the size of SSD is small, but we accept. Okay, what does the OS do? We can see one of the first things that runs when your computer starts loads, runs, and manage programs. So you can find multiple programs at the same time. This is time sharing. Time sharing is one schedule in operating system, and this is an effective schedule. Time sharing. 分时间 time sharing. Yeah. Isolate programs from each other. This is isolation. Multiple resources between applications, for example, devices. So the resources is the resources they want to know, they want to get. So all programs, all softwares want resources for us, for them. Service, we can find the file system, network stack, finds and controls all the devices in the machine in a general way. Okay, this is one image to depict the operating system. We can see this is hardware, this is the mid level, this is the up level. The up level is the user level. The mid level is kernel level. So if you have used the Linux operating system, you can see the program code in kernel of Linux OS is C program. So Linux OS is very useful and free. So you can find in all services, in all service machines, the Linux operating system is used in them. User level, you can find the shells, utilities, applications, and libraries. So if you have the opportunities to use Linux OS, you can try and you can use Linux operating system. If you have one laptop and one machine, one computer, you can set up two operating systems in one machine. But this is our model. Okay, you can see how we always have focus. Operating system used to be operator. You can see the image is ENIAC. ENIAC is from U.S. Army in 1946. So ENIAC is the first computer in the world. So you can find this is the discrimination and the depict for the ENIAC. What's different about the various operating systems? As we know, the operating system has several versions. Windows, Linux, Unix, Mac, yeah, and Android. Android is the operating system for the cell phone. Yeah. And not for the computer. Yeah. So in the computer we can see Windows, Linux, Unix, and Mac. We find Mac is an useful operating system because the Mac is very stable. I used Mac laptop 5 years. I have Windows operating system machines, but I find the characteristic of Mac is stable. It is very stable. The stable operating system is our product, is our study source. Okay, you can find a different experience for the user, different interface for applications, different levels for licensing, and availability, hardware support. But in current, we find several operating systems, different operating systems, all support all hardware. So you can find whatever Mac, whatever Linux and Unix and Windows, we can find software are run in the different OS is stable and is correct. So we can set up all software, but you see some software are not free.
Yeah.
But in China, some software we can find free version. Yeah. So in our computer, all software is free and not pay. We don't pay any cost to any company. If the software isn't free, or we can search free version, or we can destroy, or we can use another software. Okay, Linux is open source. Mac OS can only run on Mac. So Mac is only for Mac machines, but this is not correct. In the internet, we can see some technologies for we can run Mac in Taobao. x86. This structure is for Windows, but we can run Mac in this structure. But this is black Mac. Yeah. In the internet we call black Mac. Yeah. So I don't recommend black Mac because the black Mac is not stable. I try and I find the black Mac isn't stable. So don't try. Windows can be purchased, but Windows is free for China. Or in China, Windows is free. So we don't care about the cost of Windows operating system. Unix is stable operating system too. You can find in computer science, we often prefer systems that are Unix based. Unix based is stable. Mac is Unix based too. So Unix is the stable kernel. So Mac can support and can choose Unix based. Unix was developed in AT&T Bell Laboratories back in the mid to late 1960s. Built modularly strong file system called Mac OS Linux descended from this. Berkeley played a part. Berkeley is very useful, is very famous university in America. So we can see Berkeley is very tall and very famous. Windows developed independently of this Unix craze. Okay, this is operating system introduction. We can see. Okay, we can see operating system boot sequence and operating. Boot sequence is 启动序列 boot sequence. We run Windows or other operating system if we turn on. The boot sequence is correct and stable. So we find some operating systems run quick, some operating systems run slow because the boot sequence is different. Okay, we can see what happens at boot. In boot sequence or in boot operating, we can find when the computer switch off or turn on. It does the same as Venus. The CPU executes instructions from some state start address. The start address stored in flash ROM. We can see this is 1, 2, 3, 4. 1 is what's BIOS. BIOS is basic input and output system. So you can find what can find a storage device and load first sector. So you can find a storage device is your disk. Is your section C in your disk.
C drive.
So C is operating section, or operating sector in the disk. So you can find if your computer turn off, your files are stored in disk. If you turn off your machine, what can run and find all necessary files from C sector in disk. Okay, step 2, bootloader. Bootloader is a software or a system software in the Windows. If we have voice, so bootloader can run. You can find the stored on, for example, disk loads the operating kernel. So operating kernel is from C sector 2. The operating kernel files is from disk to the main memory. If the main memory has operating system kernel files, the main memory can replace the disk. Okay, you can find from disk into a location in memory and jump into it. The step 3 is operating system boot. You can find initialized services, drivers. This is in China we call 初始化. Okay, in step 4 you can find initialize is launch an application that waits for input in loop. Loop is loop and loop. So we can use desktop. So we can use Windows operating system. We see the desktop or the Windows. This is the last steps in the operating system in the boot sequence. So this is the four steps in the boot. Okay, launch application is very useful and necessary. If you have run a big software, the launch time of launch is long. If your machine is old and the configuration is too old, you can find the software, the launch time is long. For example, Photoshop,
Android Studio,
all big software need more launch time. You can find we more like modern computer, modern laptop. If we have the laptop 1 year, we want to replace. So Apple, Mark, know the minds of us. So the Apple and the Huawei and the other companies push their new product 1 year. So 1 year is the period they had discussed and they thought the customers want replace their machines or cell phones in 1 year. 1 year is a period. Okay, applications are called process. This is processes in your operating system course. You can find a process in China we call 进程. In Chinese we call process 进行中的程序. Running program is process. Program, if the program cannot run, this is nothing. If the program running, this is useful and correct. So we call progress is running program. Okay. Created by another process calling to an operating system routing, and we use the system call. System call is system, the core of system. We can find load executable file from disk. We can using the file system service and put instruction and data into memory. This memory is main memory. Prepare, stack, and heap. Set arguments, and arguments jump into the main function. The main function is probably the start and the start point. Okay, supervisor mode. Supervisor is the administrator. If something goes wrong in an application, it can crash the entire machine. What about malware? We can find the operating system may need to enforce resource constraints to applications. So to protect the OS from the application, CPU has a supervisor mode. This is another mode. We use in normal mode or current mode. Supervisor mode is 安全 mode. In supervisor mode, some uses are being limited, and we can we need isolation. You can only access a subset of instructions, and now when not in supervisor mode, you can change out of supervisor mode using a special instruction. Okay, this is the operating system. System call is system call. We find how to switch back to the OS. OS sets timer interrupt. Timer is in Chinese 定时器. Timer 定时器. It's similar like watch. Timer. So the watch is simple. The timer is complex. For example, in cell phone, you can find the timer. What if we want to call into an operating system routine? For example, read a file, launch a new process, send data. This is all routine in the operating system. We need to perform a system call. System call is set up function arguments in registers and then raise software interrupt. So interrupt is regular in some conditions. So interrupt isn't complex. Interrupt is regular. We can find if some people or some classmates make interrupt. For example, he is not safe. He is not good. We can call 120. 120 is save life from hospital. Yeah. America 999. Yeah. In China 120. Yeah. If you want to call this 110. Yeah. Yeah. So in China, the number of health services are different. This way, the operating system can mediate access to all resources, including devices, CPU. Okay, this is systems in Venice. Venice provides many simple system calls. System calls using the call in this part instruction. How to issue a system call? You can place the system call number in A0. Place arguments to the system call in the A1 section. Issue the eCall instruction. This is how your RISC-V code has been able to produce output of eCall. Details depend on the API. API is application binary interface. So eCall is the name of system call in RISC-V instruction. It is only a name. If you like, your name is Arnold, my name is Dr. Chen. So this is one symbol. Yeah. So, my daughter talked to me. He wants to change the name because the name, the spell of the name is complex.
Okay.
She told me, Dad, I want to change my name to my first name is Chen. He tell me he want to change the name is Chen Wang Wan. You know?
Yeah.
Yeah. Because this is simple. Yeah. The first name. He tell me he want to change this. I was very angry.
Yesterday when I watching a Chinese.
The child think this is simple, so this is good.
When I watching a Chinese drama, I found that their name is very difficult. So he explained that like that.
but I find I am a member from some website. I find the name of foreigners are complex. Yeah, some foreigner students, the name is long and long.
Yeah.
So we only call the first character. Yeah, this is the method. Okay, this is Venus environmental cause. Find the print string and the stock and exist print character exist too. This is the name. The name is the name. This is the description. So you can find if you look some ebook in the future, you can find some ebook. The discrimination is very detailed, and the detailed discrimination is very useful. So I like to read the ebook from English version. In Chinese version, you can see the Chinese version, the ebook of Chinese version isn't complex, isn't detailed. Yeah. And the Chinese version is from different authors, but the English version is from some famous scientists or researchers. So the English version is very useful and it is very normal. Okay, multi-programming and time sharing is very useful. So we can talk about this schedule or solution. Yeah, multi-programming is very important for operating system. The operating system, in the last running simple programming, but simple programming isn't useful for current operating system. So OS runs multiple applications at the same time. This is the demand for all users in operating system. We use the laptop or machine as one user. If the service machine, it is needed to service several users. So the service machine can run multiple applications at the same time. This is important and this is necessary. But not really unless have a code per process. So in the service machine, we find multi-core or cores or several CPUs in that service machine. So we can find the BS. We can use one structure. This is
browser.
In the service
Browser service.
Yeah, we need more and more CPUs and more cores. In the browser, we can use cell phone and the laptop. We can use one core or two cores, but this is several cores. So if you look at some service machine, you can find the service machine is big and big. in one room, and in the storage machine room, this is necessary.
Yeah.
Switch between process very quickly. This is called a context switch. Deciding that process to run is called schedule. So schedule is schedule. This is necessary. Programs can be scheduled in a variety of ways. Most resources needed or least resources needed. Fastest to run, most important. This is multi-program. So schedule, multi-program. This is similar. Okay, this is use mode. Supervisor mode, use mode, or use mode is normal mode. Use mode is multiple applications. So in the CPU we use processor A, processor B, and C, D. Okay, we can see protection, translation, application. Supervisor mode do not full isolate applications from each other or from the operating system. The application could overwrite another application's memory. Remember the linker in code. The linker is one program in assembly. The application assumes that code is in certain location. How to prevent overlaps. May want to address more memory than we actually have. Solution is virtual memory. Give each process the illusion of a full memory address space that it has come completely to itself. This is the solution, the description of solution. We can see virtual machine. From here, we can see we'll be working with two different memory spaces. You can see two different memory spaces. One is main memory, one is virtual memory in disk. VM is virtual memory. This is a large space that a process believes it and only it has access to disk. Physical memory is main memory, so PM is physical address. The limited RAM space your computer must share among all processes and processors. So the goals of virtual machine is process isolation. Isolation is 分开, yeah, 分隔 isolation. So virtual memory and physical memory are isolated and are in different locations. So, virtual machine and physical machine, the use of them are different. Make transition from infinite to finite seamless or not noticeable to the program. Translate between VM and PM addresses is the virtual memory. Okay, isolation is the virtual. Okay, this is the virtual, this is the physical. So you can find that in this image, this is the physical. The reality is in the disk. Okay, we can see add the disk to hierarchy. Use VM to mechanism to connect memory and the disk in the memory hierarchy. So you can find this is the relation. Okay, this is memory hierarchy. Register level 1 cache, level 2 cache, or level 3 main memory disk and the tape. Tape is the outer device.
Yeah.
Now, virtual memory is memory and disk. The size is page. Okay, we can see the introduction to virtual memory. Allow multiple processes to simultaneously occupy memory and provide protection. Don't let programs read or write each other's memories. The schedule is very useful and necessary. Give each program the illusion that it has its own private address space. Private is necessary. The address is 1, not 2. If the address has 2, the schedule is complex. So the address is only 1. Suppose code starts and the address, for example, this is an address. Then different processes each sync their code size and same time at same address. Each program must have a different view of memory. Okay, this is segmented memory. Divide them into segments with base and bottom. Each program has access to its segment only. A program has a virtual address range. This is the small address. This is the large address. To get location of state in a segment, you can find a physical address and to base value. Okay, this is the segmented memory. We can divide the memory from several sections. Okay, this is 5-stage pipeline. You can see in laboratory we can see 5-stage pipeline. This is complex. As you think. Okay, this is page memory. Instead of having segments of various size, let's divide physical memory and the virtual memory into equal units called pages. So the pages are the same size in virtual memory and physical memory. Pages are all the same size, regardless of program, and RAM is an integral multiple of page. Page size is the same in both virtual and the physical memory. What does our memory layout look like now? Nothing. Then we can find this is the illusion, this is the physical. So you can find the size is same.
Okay, what does page memory do?
Yeah.
What does page memory do?
What does the
memory do?
The memory do?
This memory do.
This memory? This yeah. Yeah. This memory, you can find this is shared. You can find this is main memory, physical memory. Physical memory is main memory. So we can divide the memory size to same size for the process. The size is related from the running process.
I see. What does this page memory do?
Yeah, this
the page memory.
What? This?
Our topic, page memory.
Oh, page memory. Oh, this? Yeah. This is page. This the size. The size. They call page. So the size is the same. The page is the same. So this is page memory. Each program has access to one or more pages. One page is enough. Okay. If one page isn't enough, we give more pages for the processes. pages do not have to be contiguous or next to each other, which are not organized by program. Okay, page table is the page structure. So you can see this is page table. Page table. Per program, maintain a list of pages in physical memory that they own. For each page, note the data it contains sufficient to just note virtual page number. This will help us the range of addresses. So this is the page table. The page tables you can find this is VP and this is value. If this content is known, but this page isn't wrong. So you can find in the example, this is 1 and 1 and 1. This describes effective. You can find 2, 4, 6. You can find 2, 4, 6. Yeah, we can use 3 pages in it is effective. Okay, in the other rows, we use the X to describe. Yeah, X is random. Okay, this is modern virtual machine systems. You can see protection, damage paging, and the price is address translation of each memory reference. We can see production is several programs, each with their private address space and one or more shared address spaces. Damage paging provides the ability to run programs larger than the primary memory. Virtual memory goals have several goals. Next level in the memory hierarchy. It can provide program with illusion of a very large main memory. It can work set of pages reside in main memory, or allows OS to share memory protect programs from each other. Today, more important for protection is just another level of memory hierarchy. Each process thinks it has all the memory to itself. This is the goal. Okay, we can see this is the summary. The role of the operating system. Booting a computer, we can see voice, bootloader, OS boot, initialization, base and bond for multiple process. Simple but doesn't give us everything we want. Virtual memory breeds memory, and this private illusion of independent address spaces to processes and protect them from each other. So, this is one introduction from operating system. You can study detailed knowledge in OS course. Yeah. So OS course is necessary for computer science and technology. Okay, this is the main content of lecture 18. Okay, we can find in lecture 19. The topic is virtual memory. Okay, we can see virtual memory. This is the virtual memory goals, and this is the virtual memory description. You can find the virtual address space and physical address space is two different spaces. Okay, this is virtual or physical addresses. This is many of these. This is software and hardware cores. This is main memory. So you can find processes use virtual addresses. Memory use physical addresses. This is memory. This is processor. So you can find many processes all using same addresses. Memory manager maps virtual to physical addresses. So this is virtual address. This is physical address. This section is memory manager. The left is virtual address. The right is physical address.
Yeah.
This is the memory manager map. Okay, virtual to physical address translation. The program operates in its virtual address space, the physical memory, and you can find this as the mapping. Each program operates in its own virtual address space, only program running. Each is protected from other. Operating system can decide where each goes in memory. Hardware gains virtual, become physical mapping. Okay, this is virtual memory and physical memory. Programs use virtual addresses. Space of all virtual addresses called virtual memory. We can divide into page indexed by virtual page number. So VPN is virtual page number. Main memory indexed by physical addresses we call PA. Space of all physical addresses called physical memory we call PM. We can divide into page indexed by page physical page number. So this is PPN. So VPN and PPN is in the former class, in the former structure.
Yeah, in the table.
Yeah, yes. So this is VPN. This is PPN. Okay. Each process has its own virtual memory, but all processes must share physical memory. So physical memory and the virtual memory have mapping. What is page VM? Virtual memory. Page in physical memory corresponds to page in virtual memory. This is the mapping. Okay, this is the page VM, the structure, the table, the virtual table. This is VPN, this is PPN. Okay, this is the content from the lecture 18. In today, we talk about virtual memory and OS introduction. Please study detailed knowledge in operating system course. The operating system course is very useful. Please use Linux operating system if you want to try. Yeah. But you must pay attention to, if you want to set up Linux operating system, you must step by step as a guide, because the setup of Linux operating system is very important. If you have to make some mistake, the data in disk is missing. So I recommend the setup of Linux operating system is the empty size, the empty disk. So if you have conditions, so please pay attention, because in our laptop or machines we have big and big data. Data is very useful and very important. So please pay attention if you want to set up new operating system. This is very, very important. When I was a student, my machine, I want to set up the operating system several times. So I find encouraged from the age become big and big. I find the change is very difficult because the data in our laptop or machine is very useful and important. Please pay attention. Setup is very, very cautious.
Yeah.
So, okay, today is enough. In Thursday, I will waiting for you in the laboratory. Yeah.